this video, we're going to try to tackle the question, if the voltage of the methanoic acid fuel cell is 1.45 volts, what is the reduction potential of the methanoic acid half reaction? If the reference cell was changed to cobalt-2 ion becoming cobalt, what would the new reduction potential for the methanoic acid half reaction be? What would the cell potential for the fuel cell be? What would the cell potential be for the fuel cell? Okay, so the first question is asking if the cell is positive 1.45 volts, what is the reduction potential for the anode? We know that the cathode cell potential is from here. So I know that the cathode is positive 1.23 volts minus E anode. So, I mean, I can solve for negative E anode is going to equal positive 1.45 volts minus 1.23 volts, because I'm carrying this over to the other side, so I subtract it. So the negative E anode will equal positive 0.22 volts. So E anode equals negative 0.22 volts. And that kind of makes sense. If this is 0.123 and the net cell is down here, we're going to know that this other half reaction fits into this spot. And so it would fit between the silver iodide and the nickel 2, between tin 2 and silver iodide. That was right, in this spot here, because those numbers fit in here. Okay, so that's how we would calculate the reduction potential for the half reaction of the methanoic acid. The other part of the question, though, here, so 5 says, if the reference cell was changed to cobalt-2 ion becoming cobalt, what would the new reduction potential for methanoic acid half reaction be? So when they're saying that, what they're saying is your cobalt, normally your half reaction that everything is referenced against is hydrogen. And so it's 0.22. But if we shifted it, so now 0.00 volts was here, what would the new cell potential for the half reaction be? Now, look, we said that it was negative 0.23. That would occur here. You can see that this is a smaller difference. So it should actually be small and slightly positive because it's above it. So what I will do, though, to calculate what the new half reaction is I just take the other half reaction, and that's now my cathode. So I want to just calculate the E cell, and what I'm going to use is the half reaction that was my cathode, and I'm going to use the cobalt-2 as my anode. So minus. So from here, I had negative 0.23 volts, or 22 volts, which is what we calculated here, minus cobalt, which is negative 0.28 volts. And so this is going to be positive 0.06 volts, and it's above it by that much. So that's how it would shift if I moved the reference cell from up here to down here, right? Because basically I'm just shifting where 0 is on a kind of a number line. But the next question is where the other trick is. What would the cell potential be for the fuel cell? Well, before, the fuel cell was 1.45 volts because it was the difference between this and this. Well, I don't care where you put 0 on this line, it's still the same net difference. It's still going to be positive 1.45 volts. So the net cell potential doesn't matter where the reference cell, but for the half reaction, it matters. So if they're changing the reference cell, that only affects the position, the relative numbers for the half reactions. The net of any cell will always be the same value.